Ingenuity is over. Slim landed on the moon, but it's upside down. Webb sees planets orbiting white dwarf stars, and we finally know why Starship exploded. All this and more in this week's Space Bites. Well, we got some bad news this week, and that is NASA's Ingenuity helicopter mission is over. We don't know exactly what happened, but during its last flight, it sustained some kind of damage to its rotors, and it is no longer flight worthy. And this sort of came after an interesting sequence of events, and we're still not sure exactly how they all came together. But during one of the most recent flights, Ingenuity did sort of an abrupt emergency landing. And so NASA was trying to figure out what the cause was, and they were able to see sort of why it decided that it was time to land and not complete its mission. And so they were doing some tests just to make sure that it was still working fine. And so they did a test where they had it go up to about 12 meters. So just a direct vertical flight. And it reached the top, and then it lost contact with Perseverance, which was relaying its signals back to Earth. Then they were able to reestablish connection between Perseverance and the helicopter. And then they noticed that there's damage to the rotors. And like normally, you just order a new set from Amazon, you wait till they arrive, you put them onto your drone and you're back to flying. But in this case, I don't think they're going to be able to deliver new rotors to Mars. So well over 70 flights, it demonstrated that every mission from here on out needs to have a helicopter, or maybe two. And so I can't imagine that we're going to see any future missions that don't have some component of these little helicopters joining in along the fun. So thank you for all of the science, Ingenuity. You will be missed. Japan lands on the moon upside down. Just last week, as we were recording Space Bites, we were also trying to watch the landing of the Smart Lander for Investigating Moon, or SLIM. And this was the mission created by the Japanese Space Agency, also known as the Moon Sniper. And traditionally, when you land on the moon, you have a fairly large landing ellipse that you're trying to get within, but there's a lot of debris and boulders and craters and stuff in that area. And so they were trying to show that you could land in a pinpoint area within a 100-meter landing ellipse. And we got news that they were able to land within that region, and they were able to deploy two smaller rovers called LEV-1 and LEV-2. And then we also found out that the lander wasn't generating electricity from its solar panels. And today we got pictures of SLIM. And now it's apparent why it wasn't able to generate any electricity from its solar panels. It's upside down. That's not great. And so JAXA decided they were going to shut off the lander to try to conserve its battery power while they try to troubleshoot the problem. Now, the two landers, LEV-1 and LEV-2, which I'm calling the ball thing and the frog thing, are awesome. And they're still operating independently from the lander. And in fact, they're able to communicate directly with Earth. And so they were able to supply us with this picture of the upside down lander. Now, I'm sure you're asking, like, is there something they could do? Could they bonk the lander with one of the rovers and maybe try to get it flipped back onto its surface? I don't know. I'm sure they're going to try every idea they can until the sun sets at the end of this window. But we've got a better idea of exactly what happened. So as the lander was coming down to the surface, one of its thrusters failed. And SLIM was recording its own landing with its navigation cameras. And you can see the frame when the nozzle just fell off the spacecraft. And so it's kind of amazing that it was able to actually set foot on the moon, even though one of its thrusters had failed. Maybe call Amazon and get a new nozzle to that spacecraft as well. In the cart, you've got helicopter blades and rocket nozzle. These thrusters are these 500 Newton thrusters that JAXA has used for several of its missions. It was on the Nozomi mission, on the Akatsuki mission, and they both failed on those two missions. And so this is the same thruster that's going to be on the upcoming mission to Phobos. And so maybe after 3 of them have failed, it's time to take a really good look at the design to make sure it's not going to cause any problems for any future missions. Sierra Space blows up a full-scale inflatable prototype. So watch this video. This is amazing. You're looking at a full-scale prototype of the Life inflatable habitat created by Sierra Space. And this is intentional. They pumped it up with as much pressure as they could until the thing finally failed and exploded. And they've done a series of tests, but those were with smaller versions of the habitat. This is a full-scale version of it. NASA set the requirement that the habitat should be able to support 60.8 PSI, and they were able to get all the way to 77 before the thing burst, so well beyond NASA's safety requirements. This thing is big. It's 6 meters high. It has hundreds of cubic meters of interior space. It's about a third of the interior space of the International Space Station. And so in theory, you can imagine this future where they launch like 3 of these things on 3 separate rockets. They dock them together, inflate them, and now you've got a space station that is the equivalent of the International Space Station, which took dozens of launches, hundreds of billions of dollars. Astronauts had to go outside and manually connect all of the parts together, and so maybe we could get space stations that are much more simple. All of the important plumbing and electrical work is in that inner ring, and then the outer ring inflates and you've got this habitat space. And in fact, Sierra Space is working on an even larger version of this that could fit, say, inside a Starship, where you could get, say, 1,400 cubic meters of livable space in one launch, which is more than the International Space Station. And so imagine a future mission where they just launch one and boom, you've got a gigantic space station orbiting Earth. And so people are wondering, like, what comes next after the International Space Station? Maybe it's just going to be giant inflatable stations. Now, I'm going to talk about this some more at the end of this episode, but also you're going to want to check out an interview that I did with Sean Buckley, who is the Senior Director of Engineering at Sierra Space, where we talked about an earlier test and Sierra Space's plans for inflatable habitats. Space salad is dangerous? Astronauts have to eat processed food on the International Space Station. They get regular supplies of things in foil packages, and it's tortillas and various stroganoffs that they have to then cook up in the microwave on the International Space Station, and that's their life. And they're always so happy when a new cargo capsule arrives, because generally there's fresh fruit and vegetables on board, and they're able to eat that and sort of remember what eating regular food is kind of like. But there are some experiments on board the International Space Station where they're testing out, can we grow vegetables in space, in zero gravity? And the answer seems to be yes, that they've been able to grow different kinds of lettuce, other kinds of vegetables, and in fact, astronauts have had space salads that they grew themselves. But they might need to be careful. So a team of researchers on Earth were able to show that when you grow certain kinds of leafy vegetables in a microgravity environment, then you have an increased risk of infection from various kinds of human pathogens. So E. coli, salmonella, they have an easier time being able to infect a stressed out microgravity lettuce than if it was just growing in the dirt or growing under normal gravity. And so it might be that, in fact, as astronauts are growing these plants in space, they have to be really careful about what other kinds of pathogens and infections they could be giving themselves. And so space food might be tricky to perfect. James Webb directly images giant planets around white dwarfs. Now, the James Webb Space Telescope has been imaging exoplanets around other stars, and mainly they've been using the transit method, where they watch as the planet passes in front of the star, they measure the atmosphere. But in a couple of instances, the telescope has been able to directly image the planet, like just take a picture of it. And we got a new example of this week, where astronomers announced that they had discovered 2 giant planets orbiting around 2 different white dwarf stars. And a white dwarf, of course, is like the dead remnant of a star like our sun after it's gone through all of its fuel, it's bloated up into the red giant phase, and then it's collapsed back down. And it's believed that, like, when a star goes through that process, it consumes its inner planets, but maybe the outer planets are still around. And so with these 2 planets that they discovered, they're roughly in the Jupiter mass range, somewhere between 1 to 7 times the mass of Jupiter, but they orbit a little farther away than, say, Saturn would in the solar system. And the hope is that these will help solve one mystery in white dwarfs, and that is that some percentage of white dwarfs seem to be polluted in their outer atmosphere with heavier elements. coming from probably asteroids crashing into the surface of the star. And it's believed that in fact you get these giant planets that remain around the star, and then because of their gravitational interference, they're able to channel asteroids down into the inner solar system, and eventually they can crash onto the surface of the star. And so by finding these giant planets around these white dwarfs, this helps connect this theory to the observations that have been made. And like James Webb just like took pictures of planets around white dwarfs. Crazy. James Webb solves the mystery of ancient light. Another James Webb story. So there is this time in the early universe, after the cosmic microwave background radiation, after you had all of this hydrogen and helium left over, but the universe was dark. Now, this material was coming together to form those first stars, but each of these stars was shrouded in these giant clouds of gas and dust, and so none of that light could leak out. But astronomers have found this very powerful signal seen from the early universe, which is the emissions coming from hydrogen that is changing its energy state. And they're watching as this hydrogen is passing through various clouds of gas and dust, parts of it are being absorbed, and it's called the Lyman alpha forest. And this has always been a bit of a mystery because this emission shouldn't have been able to get out of the universe from these first stars because there was so much of this gas and dust around them. But astronomers have detected it. So where's it coming from? Well, James Webb to the rescue. So Webb was able to go much further than the Hubble Space Telescope normally can, and it was able to see these large, bright galaxy areas, and it was able to detect the faint galaxies that were swirling and forming around this galaxy. And what they think is going on is that as these galaxies are coming together, they are mixing with this material, this hydrogen helium gas that's there, and they're opening up pockets and channels that this light is able to leak out and make its way through space to reach us. And so what this is indicating is that there were galaxy mergers a lot earlier on than astronomers were originally predicting. So again, like the early universe was much more active than we thought. And this is a gigantic mystery that has troubled astronomers for a long time. And so with a powerful new tool like James Webb, you're able to look much farther, much deeper, and what was just beyond the capability of even mighty telescopes like the Hubble Space Telescope, you can actually finally see this process going on and solve some of these mysteries. Every week, we do a vote on our channel where you tell us what you thought was the most interesting story of the week. And this week, the winner was Japan's landing on the moon. Now, this was before we had all of the details, but I think you're all quite excited about it, and I agree. Amazing story, and I really hope that this isn't the end of the Slim Lander. Now, you can see the vote here on our channel. You can go to the community tab a couple of days after we release this episode, as well as if you're just scrolling on YouTube, it should just show up in your feed. Of course, the best chance is if you subscribe to the channel and then click on the notification bell. What will the extremely large telescope see at Proxima Centauri? Now, one of the closest exoplanets that we know about is at Proxima Centauri, which is the closest star to the sun, just a little over 4 light years away. And astronomers were able to detect the presence of planets around this star, not through the transit method where they pass in front of the star, but with the radial velocity method, where they're able to measure the motion of the star through the influence of the planets that are orbiting around it. And so the problem is that James Webb can't analyze those planets using the transit method. Like maybe it can do the direct imaging method with its coronagraph. I'm not sure if it's tried yet, but there is another telescope that's coming that might be able to do it. And that is the European Extremely Large Telescope. This is the 39-meter telescope that's being built in Chile. It's just a couple of years away, and this will be the largest single telescope ever built. Like 39 meters. It's really hard to compare that to anything else that's ever been built. Like Grand Telescope in Canary Islands is like just over 10 meters. Like this thing's a monster. One of the things that it should be able to do is directly image planets orbiting around other stars. It'll have a coronagraph. It'll be able to block the light from the star and reveal the fainter planets around it. And so a team of researchers asked themselves, can the ELT detect the planets around Proxima Centauri? And the answer that they got under its current configuration is no. So with just the default coronagraph mask that it's going to be equipped with, it's not sensitive enough to block the light and reveal the planet. But what they said was that in fact, if someone custom built a mask to go with its coronagraph, then the answer should be yes. And you actually could be able to see the reflected light coming off the planet and try to make observations of it. And like, I wouldn't be surprised if this is the answer for a lot of the early observations that we make of planets orbiting around other stars, is that it's a custom job, that you build a special instrument that just does this one thing to image the planets orbiting some star, and that creates interesting candidates, which you then do follow-on observations with, say, the Habitable World Observatory or the next generation telescopes that are even more powerful. Now, if you like the work that we do here at Universe Today, why don't you consider joining our Patreon club? And of course, this is a chance for you to directly support the work that we do, so we don't have to do a lot of sponsorship ads and other advertisements within these episodes. And of course, as a patron, you get other benefits. And one of those is that we do every month a gigantic question show just for the patrons. We got asked 41 questions this month, and we gave 41 answers. In other words, if you are a patron and you participate in the question show, you're pretty much guaranteed to get your question answered. And these are available as an audio-only feed just to the patrons. So if you want more content, more questions, more answers, more behind-the-scenes information, definitely join the Patreon. Go to patreon.com/universetoday. Now we know why Starship exploded. So we saw the second test of the Starship Super Heavy stack back on November 18th, 2023, and everything looked great. It didn't tear up its launch pad. And then a few minutes into flight, as they separated, Super Heavy failed. And then a few minutes later, we got the news that the Starship failed as well. Last week, there was a conversation with Elon Musk where he offhandedly explained what happened to Starship. Because Starship didn't have a payload that it was going to take to orbit, it had to vent a bunch of its oxygen during flight. And so venting a whole bunch of oxygen around your rocket set up an explosive environment, and it caused the end of Starship. So future versions of Starship will have a payload, and so they won't need to do this oxygen venting. And so this is probably going to be a non-problem. And it'll have to be other issues that SpaceX faces as they try to make their way to orbit. And so if this is such a minor problem, then we could be seeing another test flight of Starship in the next couple of months. And so for the last mission, I had a great conversation with Scott Manley and Marcus House, and we sort of went through in detail what happened with the mission, why it seemed to have failed, and now I guess we have more information now. But still, if you want a really interesting analysis of what happened with that second launch, check out that video. Landspace tests its reusable booster. In the United States, SpaceX is just running away with the launch market. And the big part of this is because they use these reusable booster rockets like the Falcon 9. Running a close second to the number of launches from SpaceX is China. And they launch an enormous number of rockets every year. And several companies are working on their versions of reusable rockets. And so this week we got a test from a company called Landspace when they tested their new reusable booster called JWST. Now, it took off in the Gobi Desert. It flew to an altitude of about 100 meters, was in the air for about 60 seconds, and then landed within just a couple of meters of where it was supposed to. This is the final width of the rocket. It's about 3.35 meters across, but it's only about 1/4 the height of what the final booster is going to be. This is a way for them to demonstrate that their reusable landing system works. And so with this test out of the way, they're going to move to larger prototypes, and they're hoping to have their first actual reusable flight in 2025. Like SpaceX with its Raptor engines, like Blue Origin with its BE-4 engines, they are using a Methalox engine. Theirs is called the Tianque 12, and it is 80 tons. But the point here is that China is catching up in the reusable launch market game. And I wouldn't be surprised if in a couple of years, many of their rockets are reusable, like SpaceX. As I said, I'm going to talk about inflatable habitats a little more. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Hey Twilight, Dougie Stewart, Stephen Krasaki, David Richards, Mark Ansis, Joel Yancey, and Tony Lofilara, Dustin Cable, Vlad Shiplin, Modso, George, David Gilton, Andrew Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I really like the idea of inflatable habitats. And I think initially you look at it and you go like, isn't that dangerous? It's a balloon in space. Couldn't it be popped by a piece of space debris? And the answer is no, that you surround these things in multiple layers of like Kevlar and other fabrics that are designed to absorb impacts. And in fact, it's a lot safer than a rigid hull made of, say, aluminum, where a piece of space debris will just punch right through. It'd take a pretty large piece of debris to actually make it through the habitat shell. And NASA's been testing out these ideas of inflatable habitats like since the 1960s. But things got pretty serious a couple of decades ago with Bigelow Aerospace. And they were proposing various sizes of inflatable habitats. And they even got one launched to the International Space Station called Beam. Unfortunately, Bigelow filed for bankruptcy, but there are other companies that are working on this idea. And Sierra Space is one of the main ones. We talked about the prototypes they're working on. And we talked about like what the larger versions of this could be in the future, both on more conventional launch fairings as well as something bigger like on Starship. But there are a lot of other ideas that you could use these inflatable habitats for. Back in the 2010s, NASA was thinking about, could we use an inflatable habitat as a way to provide artificial gravity on the International Space Station? Imagine like an inner tube tire that you inflate that is this torus that you attach to the side of the space station, and then you rotate it. And then the astronauts can go into this module, sleep, exercise, live under some level of artificial gravity, and then come back to the rest of the space station. Now, it never happened because the cost was too high and they had other priorities, Artemis, Webb, things like that. But I could still imagine some version of this happening in the future. They're also investigating inflatable modules that could go to the surface of the moon. And so maybe the first permanent station on the moon is just going to be this inflatable habitat that has been set up on the surface of the moon. I think that inflatable habitats are going to play just a really big role in the future of human space exploration. And I wouldn't be surprised if the majority of places that humans live in space are inside inflatable habitats. All right, we'll see you next week.